Sorry about that interruption. I guess this will actually be the final video for our 2-day lesson. We're going to pick up here with problem 3 of lesson 12.4, where you'll see we have 2 box and whisker plots on one number line. So what's happening here is we're looking at the average monthly rainfall in inches, and we're comparing Miami, Florida, and New Orleans within the same set of parameters. We're going to use this box and whisker plot representation here, and we're going to compare their IQRs. What does this tell you about the average monthly rainfall for each city? Now, even though we see the word average here, that's just connecting to the title. We're worried here about IQR, which is a measure of dispersion or spread. So IQR is the range of the box, and without doing any calculating, we can see that Miami, Florida has a wider variety of average rainfall than New Orleans does. So we can already jump to our answer. Since the box is longer for Miami, that means it has a larger IQR. That means that the middle 50% of our data of Miami's monthly rainfalls vary more widely than those of New Orleans. Another way you can phrase it is that New Orleans' average rainfalls are a lot more consistent since the box is much smaller. For Got It 3, we're going to use the same set of data, same 2 box and whiskers, but this time we're going to look at a measure of center. It wants us to look at the medians and state a claim as to what this information is telling us. So if we look at our medians, back up here, that's where the box is split. So we have a median about a little under 4.5 for Miami, and for New Orleans, it's a little bit higher, about 5.2 or 5.3. So this tells us that for Miami, half of the rainfall values are above and half are below about 4.5 inches. For New Orleans, half of the values are above and half below about 5.25 inches. So the middle data values trend higher for New Orleans. It's a little bit fancy of a way to phrase it, but basically the median value is higher for New Orleans than it is for Miami. So even though Miami, it has a wider variety and is less consistent, New Orleans does tend to have more rainfall based off its median. Okay, so that wraps up the box and whisker plot. There is a final portion to these notes, and it has to do with percentiles and percentile rank. So this is something that is going to be an extension. Due to us condensing these lessons, we're not going to spend time actually practicing these on the assignment. So at this point, if you want to stop watching, you can. If you're wanting to at least watch and see what percentiles are and how they work, it won't take very long. So percentiles are separate data set. They separate data sets into 100 equal parts, and they make it so that you can speak as a percentile rank. So the percentage of data values that are less than or equal to that value is going to be considered the percentile rank of the data value. So here's how it works. Got it for part A. Of 25 test scores, there are 15 scores less than or equal to 85. So the percentile rank of 85 would work as following. There's 25 test scores, 15 scores less than or equal to 85. So 15 out of the 25, this would be a percentile rank of 60. Think of it as an actual percent. 15 of the 25 scores are less than or equal to 85, so be about 60%. And a real-world connection I made when I first wrote these notes, the same day I wrote these notes for you guys, I read an article about percentiles of babies' heights and weights. If a baby is on the 75th percentile for length or height, this means that 25% of the babies his age are taller than this baby, and 75% of the babies his age are shorter than this baby. So that's just kind of how percentiles work in the real world, in case they ever pop up. But again, that will not be part of our lesson for now. So that officially wraps up our 2-day lesson for Chapter 12, Lessons 2, 3, and 4. If this does not help and you have more questions, please make sure you email me, and I will do the best I can to get you answers.